Okay, hello everybody. Welcome to our second Globe Observer Connect for March. We're excited to have some information for you about the Blowing Snow pilot project that we ran from December until the end of this month, so technically until next Tuesday. And our presenters today. So first of all, I'm Kristen Weaver. I'm the Deputy Coordinator for Globe Observer. And just a reminder that we are recording this session. So if you don't want to have your video on the recording, please leave your video off. You can put questions in the chat. We will do questions at the end. But just know that we are recording it. So our presenters today, we have Bill Line, who is a physical scientist with NOAA NESDIS in Fort Collins, Colorado, and is the STAR Image Science team lead. And so in his position, Bill collaborates with researchers at CIRA and operational forecasters to conduct satellite-related research and to develop imagery-based products and best practices. Previously, Bill was a forecaster with the National Weather Service in Pueblo, Colorado. And then we also have Christy Buffington, who is a science education director and program manager at Geographic Information Network of Alaska at the University of Alaska Fairbanks, joining us very early this morning. That network is a satellite remote sensing data center that provides near real-time satellite data to support weather forecasting, including blowing snow, wildlife monitoring, and research. Christy is an environmental scientist and former teacher who also serves as the Deputy Director of Training, Education, and Public Engagement for the Globe Implementation Office. So without further ado, I'm going to pass it to Bill, and we will get going. And after their presentations, there'll be some time for questions. Thank you all for being here.
All right. Thanks, Kristen, for the intro, and Holly for organizing, and Christy for helping organize as well. And most of all, thank you to all of you Globe observers for contributing to this project. This is, I think, a really neat collaboration. I'm excited to talk to you all about it today, specifically the project that I'm involved with in developing a new satellite-based blowing snow detection product, and how your observations help us in that development. So we'll jump right in. I wanted to first very briefly go through some background into our satellite information, because it might be new to many of you. So from NOAA, NOAA is the National Oceanic and Atmospheric Administration, where I work. We operate really two flavors of satellite. There's the geostationary satellite, weather satellites, that basically sit over the equator, over the same spot, scanning the same area. You can kind of see how that scanning works here, including the United States, over and over and over. And that allows us to get images every 5 minutes over the United States. Very high temporal resolution, and the latency of those images is very low. So we're getting those images pretty quick after they're scanned. And then the other flavor of satellites are our polar orbiting satellites. Those are known as the JPSS, Joint Polar Satellite System satellites. They also collect imagery of the Earth, and they are actually rotating around the globe over the poles, as you can see in the bottom animations. And you might look at these two and realize why we need both, because the geosatellites are not able to scan the poles. So we have these polar orbiting satellites that are able to scan the poles at a very nice resolution, so that they work together, and we need them both. And in projects like detecting blowing snow, both of these satellites are capable of capturing blowing snow. I mainly using the JPSS satellites for blowing snow over places like Alaska and the North Pole, and then our geostationary or GOES satellites over the lower and mid latitudes, including the United States. So blowing snow may seem obvious, but there's some nuance to what exactly it is. Basically, it's snow that is on the surface, fresh snow, usually freshly fallen snow, that is getting wafted by strong winds. It's not snow blowing across only the surface, but it's going to be lofted feet to meters and tens of meters into the air, so that it significantly reduces your ability to see across the horizon. So of course, this poses a considerable hazard for both air and ground transportation. You might have clear skies, then all of a sudden you drive into one of these blowing snow plumes and your visibility goes from great to nothing in a matter of seconds. So the National Weather Service does issue forecasts and warnings for blowing snow. So they really want ways to detect it, but it's really a subtle feature in observing systems. And so traditionally they're primarily using things like webcams and ground photos, but they can be sparse. So we wanted to come up with this way to be able to detect it in satellite imagery so that they could more easily and more efficiently detect blowing snow. So that's what we've done with this product called the Blowing Snow RGB. RGB stands for red, green, blue image. We're combining various channels basically that these satellites sense the Earth in to be able to best highlight the blowing snow feature. So oftentimes what we're seeing in this product is basically these blowing snow features, or we call them plumes, organized into something called horizontal convective rolls. And it's these features that are kind of mature regions of blowing snow that are associated with strong winds and from our research, blowing snow and reduced visibility at the surface. And these features often stretch tens of up to even over 100 miles for a single plume of blowing snow. And they're oftentimes very linear features. So very quickly on the project, basically this is your first look. This is over Northern Alaska at the product we developed, the Blowing Snow RGB. Basically, again, we combine channels from our satellites to get this colored image. And what forecasters look for is this kind of bright greenish color, or maybe sometimes a pinkish color against the otherwise snow-covered background, which is usually red. And you can see how you're not just looking for the color, but you're looking for these organized or linear bands or plumes. So you're looking for that texture that is unique to blowing snow. So that's what we're looking for as forecasters in the satellite imagery. But we want to make sure that what we're looking at in the satellite imagery is actually blowing snow and not something else. So that's why ground truth is extremely important. So what we use to confirm what we're looking at is actually blowing snow, things like surface observations, so like ASOS sensors that sense the wind, and at airports, observers will actually know if it's blowing snow. We have very high resolution satellite imagery every couple of days that can help confirm it. Webcams we use, and of course photographs, and that's where you all come in. Photographs from folks across the country, especially the plains where blowing snow most often happens, are extremely important for us to be able to confirm what we're seeing in the satellite imagery is actually blowing snow, and be able to assess the degree of blowing snow that we can actually see in satellite imagery. So just some of my tips for observing blowing snow and you at the surface being able to take an image of blowing snow. I understand it's very difficult to know what's blowing snow or what's snow that's actually falling from the sky, but at the very least, you definitely need to have strong winds because you need the winds to loft the snow. You need to have loose snow on the surface, so it can't be crusted over melted snow. It's got to be kind of a freshly fallen snow. It's loose. You have to have the strong winds across that loose snow to be able to lift it. And then, of course, you need to have reduced visibility to go along it, up, multiple feet or meters into the air. You want to, of course, watch for the snow lifting off of the ground, maybe going with the wind, and then again a hazy near surface appearance. You might, since these plumes are linear and often kind of spread out, you might be in and out of a plume. So it might be clear, then all of a sudden you see this feature approach, and then your visibility goes from great to nothing. So that's kind of what I would recommend looking for. So now, just some quick examples. This one's from a little while ago, but it was one of the early examples of when we had our RGB developed and forecasters starting to look at it. On the left is the GOES, the geostationary version of it. Then on the right is the polar orbiting version. And then on the bottom is a webcam photo showing the blowing snow. So not only can you see the snow blowing across the road, but it's obvious that the visibility across the horizon is considerably reduced too. And that's because they were under one of these plumes. So the cyan or blue colors are actually clouds. And then again, these more mustardy, sometimes green, sometimes yellow features are the blowing snow plumes. So this one more recently from a couple months ago in January, this coming out of Saskatchewan between these two cloud areas. You see these plumes of blowing snow moving southeast into northwest North Dakota. So I highlighted them there. And then this webcam footage from Saskatchewan, Weyburn, you could actually at times see the plumes kind of in the distance, and then at times the little webcam is in the plume, and you could see like these trees in the distance become obscured at times, and that's because they're kind of in and out of these plumes that you could see in the imagery. This example from January 26th, so kind of similar timing from the last one. You could see plumes develop during the afternoon over again, the red is the snow cover, the blues and purples and cyans are clouds, and then these kind of linear streaky features are the areas of blowing snow. So a forecaster would look at this and be able to tell where the blowing snow is so they could update their forecast, issue a warning if they need to. Surface obs help show where you have reduced visibility, and then again, webcams where you have them show the periodic visibility reduction. But you can see in this case, looking at the surface obs of this area, reduced to 1 mile visibility. Here in Grand Forks, a half a mile within this plume, another 1 mile over here, 2.5 miles further to the west. So surface obs and then webcam helping. But if we had folks taking photographs within this region as well, that's even more useful. For example, what does the visibility look like in this really thick, tall plume compared to maybe the more flatter appearance plumes? That could be helpful. Then again, also confirm across the full extent of this area where exactly blowing snow is occurring. Another example of this, looking in the Red River Valley. So this whole mass of clouds slowly shifting to the southeast is dropping snow beneath it, and then behind it, that snow is blowing and actually organizing again into these blowing snow plumes. So here's a photo from within those plumes. You could clearly see, again, not just the snow streaking across the roadway, but if you look along the horizon, you can't see more than, definitely not more than a mile, signifying that this is certainly blowing snow. And then one more example from Alaska, from last year, northern Alaska. You could see how the GOES imagery is very blurry because as you look further and further toward the poles, the imagery pixels basically become stretched. So that's why then we need to use the VIIRS imagery, such as what I have below, to get the more detailed imagery. And again, you could see the streaky appearance of those plumes. And then for this example, we had nice ground truth from some webcams up there. Here's a radar. You could see, again, horizontal visibility reduced. But if you look up even further, you could actually see clear skies. So again, it's not snow that's falling and blowing that we're interested in, because we can't see through the clouds anyway. We want snow that's actually blowing off of the surface. So a couple of examples of your great photos that have been really useful. This one from January, north of Toledo, looking south, basically looking south at this cloud shield, which you can actually see in this photo, which is pretty neat. But looking at the imagery, there, at least what we could see in the imagery, could not see blowing snow, but that doesn't mean it wasn't there. And that's why another way your photos are helpful in telling us what kinds of blowing snow we can't see. And in this case, the observer clearly took a photo of snow blowing across the roadway. So there's clearly, this is technically called drifting snow when you have snow moving across the surface, but the blowing snow we're looking for would be lofted up into the air, again, to reduce the horizontal visibility. But still good to know that, yeah, this type of snow, this drifting snow, is something that we want to be able to see in satellite. And it's not really as harmful, again, because it's not restricting your visibility. Then one more example. This is kind of a case where we would be unsure if it was blowing snow from this photo from one of you in January in central North Dakota. Again, clearly see blowing snow across the roadway. This would be drifting snow again because at least from the photo I could tell it's not considerable reduction of horizontal visibility, though it does look like there's some reduction in visibility along the horizon. So in this case, I would say maybe there is blowing snow, though the surface, from what I could see, doesn't look like there's much snow cover to actually be lofted and blown. And then looking at the satellite imagery, it's shrouded in widespread cloud cover. You don't see those obvious blowing snow plumes. So in this case, I would say this is more likely snow that's falling based off of the imagery, and we could probably look at surface obs as well. But there's a chance that snow is blowing as well. We just can't see it because we have cloud cover. So again, another great example of photo from you all. So that is the end of my slides. I hope this helped be able to identify what is and maybe what isn't blowing snow. This has been a great collaboration. Excited to continue it, hopefully into the future, to be able to use your all photos to be able to confirm what we're seeing or not seeing in our satellite imagery. So now I'll pass it on to Christy to show some of the tools we're using in this project.
Yeah, thank you so much, Bill. That was a great presentation, and it shows, really what you do every day to look at. First of all, you develop this blowing snow product, and then you use that product to look at satellite remote sensing data, and then you do compare it to ground observations. I just want to give a little bit of background that this idea came from a conversation that you and I were having in January of 2025 at the virtual Alaska Weather Symposium, where you were a presenter. And I asked, do you need photos, ground photos? And you said, sure. And what's so cool about Globe is that it's already built to do exactly that. And Globe, for those of you who might be new to Globe on this call, there is a Globe Observer app. And within that app, there is a clouds tool. So we were asking people to use Globe Observer clouds to photograph the snow. And then this last calendar year, the Globe Observer team and clouds team made it possible to take feature photos. And so we asked for feature photos across the horizon, and we'll show some of those here today. And I also want to thank many people who collaborated on this project. Many of you are on this call from Geographic Information Network of Alaska. So I'm going to show Hannah Mayer made the dashboard that I'm going to show you, and then NASA Globe made a quick look where you can see all of the photos, and we needed those photos organized into a map. So Hannah, if you want to turn on your camera so people can see you, and if they have questions, they can ask you about this. So I'm going to ask to share my screen, and I am going to share a window here.
Yeah, and you should, don't know if we tested your sharing, but hopefully you're able to.
Great. And here we go. We also have Carl Dirking on this call, and his photos of sea spray is really what led to us thinking, can we do this with blowing snow as well? So thank you, Carl. Carl is also a meteorologist who works with us. So here we have the map that the web viewer or the dashboard that Hannah has made. And what you see here on the legend on the left, you can see it's kind of a workflow so that we can provide to Bill this tool and to anyone. And you can see what observations might have come in the last 48 hours. Now, we don't see any now, but we see that some recent ones that are last 2 weeks. And we see here the darker color here more than 2 weeks. We have, these are the ones who have photos. So what we have is this toggle where you can see the ones that have photos. These are the ones that have a feature photo. Those are the ones that we really want because it's the photos across the horizon. And then we also want to know a little bit about what you're seeing, so captions or comments. And I absolutely want to give a huge thank you to Captain Shannon Babb, who is on this call, and the Civil Air Patrol, because they have been participating as well. And once you zoom in and you see all of these Civil Air Patrol sky conditions observations, they went out whether it was blowing snow or not and did their aviation weather mission protocols. So they did the whole clouds tool rather than only blowing snow observation. So you can see that you can zoom in on this map, and then we had observations from all over the world that came in, and we can see some, you know, here off a ship coming into Antarctica, and there were, you know, photos here. You could see not great visibility, and it was really fun. Bill and I sat down together over Zoom and looked at all of these photos, and he pulled up the corresponding satellite imagery and decided this might be sea spray or clouds. So I just wanted again to thank everyone, show you this tool, and kind of talk to you about our process. And now we have about 7 minutes left. We have learned a lot about personally what we might be doing differently to actually get that positive confirmation of blowing snow. We're asking people to find a needle in a haystack. So it would be really fun to hear from you, your questions and your ideas about what could be done if we were to do this pilot project again next year, because we would certainly like to if funding is available.
So yeah, so folks, if you have questions, feel free to put them in the chat. You can also raise your hand, and we can do it that way. I don't see any in the chat yet. I guess one question that I have is, so you're detecting blowing snow as it happens. Are there predictions that you can do? Do you try to model the right conditions and do predictions about when an area might be more likely to experience blowing snow versus not?
Yeah, the Weather Service has formulas that they put into their forecast to basically spit out whether blowing snow might occur or not, and then they'll use their expertise to put it into the actual forecast that goes out. So yeah, certainly there's ways to do that. And they do. So if you go to your weather.gov and click on your location, they'll have in that forecast, the gridded forecast will have blowing snow, and then you could actually go in and read their forecast discussion and they'll talk about it. But yeah, this satellite part doesn't go into that yet, but this kind of product can actually inform their predictions by actually showing the Weather Service forecasters whether their modeled predictions were right or not. So maybe their forecast model showed that there would be blowing snow, but then they could look at this and say there actually wasn't. It was clear with no snow, and then that could help to improve their forecasts.
How time bound are those predictions? Is it just sort of in the next day, or can you narrow it down to a few hours, or how fine tuned can those predictions be?
Yeah, usually maybe they'll forecast blowing snow out a day or two, and then yeah, like day of they can constrict it to from 11 a.m. to 4 p.m. is the most likely time for blowing snow, because a lot of it's based off of the wind speed. So they have wind speed thresholds. They have, of course, snowpack requirements, and then things like temperature and humidity could play into it as well.
So we do have a question from Captain Shannon Babb, our contact with the Civil Air Patrol, as Christy mentioned. Would there be interest in participants being able to differentiate between blowing snow, drifting snow, and other conditions like snow squalls in their observations?
It could be. I mean, yeah, I don't expect folks to be experts in being able to differentiate that, because I mean, it's hard for me to be able to do that. I think it would be hard for anyone. They could try and use their best judgment, or maybe better would be just as detailed as they can, detailed description of what's happening. Um, is snow falling from the sky? Is the snow on the ground loose and fresh? Yeah, did it snow yesterday? Is there cloud cover in the absence of the blowing snow? I think things like that would be more useful than the actual observer trying to decide for themselves what it is.
Maybe some diagnostic questions that can help indicate whether the
Yeah,
conditions are happening. Because you said, I mean, some of those photos of drifting snow sounds like it's not necessary. If there's not a visibility issue, then it's not as dangerous, which it sounds
yeah.
like is one of the key reasons that we care
Mhm.
about this, is because these blowing snow conditions can be
Yeah.
dangerous.
Yeah. But I would be hesitant to say not to send a picture of something like drifting snow, because maybe it actually is. I wouldn't want people to not send a photo because they think it's not what it is when it might actually be.
Okay. So
I
basically,
agree with
better just
that.
to take the
Yeah.
photos and yeah.
Yeah.
We have Joy Hamilton from Onoco River School here, and thank you so much for so many observations, Joy. And I think that just by seeing this time series in the same place, even though those weren't actually blowing snow, there's a lot of drifting. And so now we have this time series from this one place, and you can see where the drifts are accumulating over time. And then that's local data, but also, regionally, people can start to see, here's what's happening in this place. So I could see, but one thing that's really interesting and fun from a research perspective is then, great, like all of these ideas, now we have to give back to the community and say, we looked at this and here's what we think. And here's what local communities can do with that data as well. So that if we were to scale this up, it would be really neat to have that feedback built back in. And then also the forecasting, like, we think blowing snow is here. Could you go out and take
Yeah, and that's
photos
sort of
in
what I
these
was thinking about,
conditions?
was being able
Yeah.
to sort of let people know, hey, the conditions are right in your area. Can you watch for this and take observations? It'd be great. We don't quite have the ability to do that with the app just yet, but maybe at some point. So we did have, I think, Joy from Anoka River School, as you mentioned. It is early there, I know, in Alaska. So she says she's curious, do you have local airlines that are using the data yet? We have blowing snow here, but I haven't seen any that obscures the runway. It would be fun to set up a ground level anemometer at our runway, and aside from the FAA tower data that's at the runway there. So
Yeah. Yeah, I don't know. It would the We have all of our imagery online on the Sierra Slider webpage, which I had in the slides. So they certainly could. But at the very least, the Weather Service has the imagery and they're using it, and then they provide the forecasts for the airports and surrounding areas. So it's getting to those areas. But yeah, I think airlines, if they have their own meteorology groups, would be free to use that information as well.
Yeah, and mushers too, and snowmobilers. People in Alaska getting around need to
Mhm.
see what's happening. So,
Yeah.
yeah, Joy mentioned that in the chat.
and I think, Christy, you said you recently, on another meeting we were on, you said you recently had an experience with blowing snow while trying to fly somewhere.
In fact, a civil air patrol, it's very interesting. So about 2 Saturdays ago, I was trying to, my granddaughter and I were trying to get back to Montana. And we were on the plane, and the pilot said, sorry, we can't land. We have to turn around and go back to Seattle because of blowing snow. And so, of course, back at the airport, I pulled up Bill's slider tool to go find the blowing snow over Montana. And then meanwhile, Civil Air Patrol elsewhere in Montana, where the storm was actively falling, got observations, and then Captain Babb shared those with us. So the collaborations in this project have just been astounding. And we did this on us, like, we just did this, right? The teams, Globe Observer, Clouds, Bill and everyone at NESDIS and STAR. I mean, we made this happen on a shoestring budget and an idea. So thank you, everyone.
And I think, yeah, so the links for the Blowing Snow Quick Look and the Blowing Snow web map are in the chat, and we'll make sure when I get this recording ready to go, we also include those links so people can explore those themselves a little bit. We are at the half hour. So I think we try to keep these sort of short and sweet, but sort of reporting back. But stay tuned, because we are not. It's the end of winter now, and for us, and we'll see what we can do for next winter season and doing more observations. I think the GLOBE program is going through some transitions right now, but we're hopeful that we'll have the capacity to do a similar thing. I mean, this was intended to be a pilot to sort of test things out, and we got at least a few examples, maybe not any actual blowing snow, but at least some photos to look at. And so just stay tuned, and we'll definitely let everybody know by what we're able to continue doing. But we really appreciate everyone who joined today and all the observations that got sent in, and to Bill and Christy for sharing sort of the lessons learned in the process here, and for Hannah that sounds like created that great visual display that we very much appreciate. So yeah, thank you very much, everybody. Have a wonderful rest of your day.
Thanks, everyone.
Yeah, thank you,
it's going to be 80 degrees here in the DC area, so it's like thinking about blowing snow and the weather outside is very contradictory right now.
And in fact, we had a bit of a slow start in December. There were a few blowing snow events over the holidays. Yet, trying to get people to think about blowing snow when it's, 70 degrees in an area that would normally have snow is kind of hard.
It certainly was not the best year for blowing snow, that's for sure.
Yeah, well, that's something we have no control over, right? Yeah. So anyway, well, have a wonderful day, and I will send out the recording link. We'll get it posted as soon as it's ready to go, and send it out to everyone who registered.
Great. Thank you so much, Kristen. Thank you, Holly, and thanks everyone with GLOBE and NOAA NESDIS and here at GINA.
Yeah, take care, everybody.